Hi guys, we are going to talk about 1.8 notes today, which are all about functions and using rules and tables, which is the basis of algebraic concepts. So open up 1.8 notes. I'm going to do a little bit of talking first about 1.8. I'm going to give you some real life examples that will hopefully make a little bit of sense to you when we're talking about it in math terms. So we're going to talk about functions. A function is basically like a rule. So for example, if you cut class, you're going to get a detention. Okay. And that would be the same for you. It would be the same for the person sitting next to you in class. Um, that's what happens. So a rule just means that something is happening to something over and over and over again. Um, so the relationship that I give, or the example I give, is think about you using Play-Doh. I know that you've all played with Play-Doh in the past. Maybe you've had like a Play-Doh spaghetti maker. We're going to use that as the example today. So if I take the Play-Doh and I put it into the Play-Doh maker, spaghetti is going to come out. But if I do orange Play-Doh goes into the spaghetti maker and orange Play-Doh comes out. If I put purple Play-Doh in the spaghetti maker, purple spaghetti is going to come out. If I put blue Play-Doh in the spaghetti maker, blue and green can't come out. Only one thing can come out. So there's a direct relationship between what you put in and what you get out. So let's think about this in math terms. Okay. So let's think about X as being our inputs, or what kind of Play-Doh am I putting into the spaghetti maker? And then Y is the color spaghetti that's going to come out. And we have to determine, is this following a rule? So basics of this table is there's going to be some options. So let's just start with 1 to 6. Let's see if we can figure out a rule. Well, the easiest thing that we could do to a 1 to get to a 6 would be to add 5 to it. Another option would be that we could multiply by 6. Those are two different rules that would work to get from our 1 to our 6. So now we have to determine which of those rules fits all of the X values. So let's try moving on to 2. 2 plus, let's try the 5 rule. 2 plus 5, is 2 plus 5 12? No. So that means the plus 5 rule does not work. So let's just check the multiply by 6 rule for all of these. 2 times 6, is that 12? Yes. 3 times 6, is that 18? Yes. And 4 times 6, is that 24? Yes. So that means the rule of this input-output table is multiply by 6. Okay. An easy trick to actually solve these input-output tables is by just looking at your X values, about your inputs. So as long as you have no inputs that are repeating that go to different outputs, this is going to be a function. It's going to work. There's a rule that goes along with it. So there just can't be any repeated X values. Y's could repeat. Okay. So that takes care of the front of the notes. So let's go on the back and let's actually apply it to some real life examples. So we're going to talk about if these three tables are functions or not. If they are a function, I'll then explain what a domain and a range is. So with this first one, we are just going to be looking at just the X values. And we see that there's no repeats. 2, 4, 6, and 8. There are no repeated numbers, so that means number 1 is a function. We're going to answer yes. This is a function. It does work. And again, there's a second part to the notes. If it is a function, you're going to state the domain and the range. The domain are just all of your X numbers listed out behind the letter D, or you can write the whole word domain. And your range values are all of your Y values, again, just listed after using the letter R. So because this is a function, we're going to state the domain. So our domains, the numbers are 2, 4, 6, and 8. Our range values are our y's, or our output values, and those are 8, 10, 12, and 14. And that's all we need to do for that problem. So let's move on to the second table. We're going to look at our x values again, but this time I see an x value that repeats. I see a 4 and another 4. So what we need to do is we need to go check the ranges or the y output values to make sure that those are different. And because they are different, these repeating values right here do not work. You cannot have any repeating x's that go to different y outputs. So that means this number 2 is not a function. So we can just answer no. In the third table, I'm going to look again at our x values to see any repeats. And I do see a repeat, the 7. So let's just make sure 7 goes to 23 and 7 goes to 8. That can't happen. So this is like 7 being orange spaghetti. If I put orange spaghetti out up here, a 7, I should get a 23. And if I put orange spaghetti in down here, I should get another 23, but I get an 8. So that means this is also not a function. Okay. So what we're going to start doing is we're going to use order operations to make our own tables, and then we're going to graph them below. So let's just first start with the making of the tables. So your tables you're going to want to look a lot like the ones in number 1. But what we're going to do is we're going to add another little extra space to this to allow us some room to do some work. Okay, so I'm going to give us an input column to the left, and I'm going to give us an output or a Y column to the right. And we're going to do all of our work inside this middle column. And all of the work inside the middle column is going to follow this equation. Y equals X plus 4. And remember, the domains are all of your X values. We're going to put in a 0 as X for the first. We're going to do 1, 2, 3, 4, and 5. We're going to do this 6 times. So what I'm going to do is I'm going to put this number in place of X. So 0 plus 4 is 4. So we now have the ordered pair of 0, 4. Now I have a 1. I'm going to put a 1 in place of X. 1 plus 4 is 5. I'm going to put 2 in for X. 2 plus 4 is 6. 3. 3 plus 4 is 7. And I don't know if you noticed, all of our input values follow a pattern. We're adding 1 each time. You'll also notice that if your X values follow a pattern, your Y's will also follow a pattern. So I could predict that if I input 4, I'm going to get 8 as an output. If I input 5, I'm going to get 9 as an output. And I can prove that by just following the pattern. 4 plus 4 is 8, and 5 plus 4 is 9. So you have space on your paper. I'm going to have to scroll down. So write this before you move on. And the second part of this is that we're going to draw the line to graph those functions. Remember that when we had the input of 0, our output was 4. That correlates to an ordered pair where X is 0 and Y is 4. So you know, these numbers down here at the bottom are all of your X values. All the numbers that are on the vertical axis are all related to your Y's. So what we're going to do is we're going to find these points on our coordinate plane. So we're going to go to 0, 4. So that means I'm not going to go right anywhere to 4, 0, but I'm going to go up to 4 on the y-axis right there. My next point was 1, 5. So I'm going to go to the right one, up 5. Next will be 2, 6, 2, 6, 3, 7, 4, 8, and 5, 9. You will notice that these 6 dots should allow you to create a perfectly straight line on your coordinate plane. If they don't, you made a mistake somewhere. Okay, let's try the second problem, which is a 2-step problem. Okay, we're going to still set it up exact same way, where I'm going to have an input of x and an output of y. This time, we're just going to be inputting 0, 1, 2, 3, and 4. And we're still going to be using the equation y equals 3 times the quantity of x plus 2. Okay. So I'm going to first plug in 0 in place of an x. So it's 3 times 0 plus 2. And order of operation tells us, hey, do what's inside of the parentheses first. So 0 plus 2 is 2. 3 times 2 is 6. The second one in a different color. I'm going to put in 1 in place of x. So it's 3 times 1 plus 2. Again, order of operations tells us do what's inside the parentheses first. 1 plus 2 is 3. 3 times 3 is 9. Okay, we're now going to put in a 2 for x. So 3 times the quantity of 2 plus 2. Again, same steps. 2 plus 2 is 4. 3 times 4 is 12. And again, I think you might have noticed by now, if your x inputs have a pattern, 0, 1, 2, 3, and 4, your y outputs will also have a pattern. And I don't know if you've caught, we were just counting by threes, but we started at 6. So 6, 9, 12. Next would come 15. And lastly would become 18. And if you do not feel comfortable with that pattern, you can just continue by doing all the work inside that middle table. And now that we have our table complete, you should be able to also now plot these on a coordinate plane down here at the bottom. So we have the first point as being 0, 6. Second point, 1, 9. Third point, 2, 12. 3, 15. And 4, 18. And you will also know that these 5 points should create a straight line on your coordinate plane. Okay, so when you're doing the practice tomorrow with this, please make sure that you show all of your work by making a table, by graphing these lines on coordinate planes, and showing all the work that you need to. Any questions? Just please message me in Schoology, let me know that you're struggling, and we can set up a time to meet, discuss, do a Zoom, do a Schoology conference, whatever you need. Okay, good luck.